Okay, so an electron is accelerated from rest through some potential to a velocity of very fast, right? Notice that that velocity, though, even though it's fast, is small compared to the speed of light, right? So this is E6, right? Speed of light is 3E8. Okay, so this is small compared to that, right? Once you get to 20% of the speed of light, what we're doing here doesn't work. But anyway, let's take a look at this guy. So basically the field is the potential energy is the charge times the voltage, right? Or we could say change in is change, right? And then that is going to turn into kinetic energy, which is 1/2 mv squared. So eventually we just get Q delta V, and that's the voltage, right, is equal to 1/2 mv squared, where that's the velocity, right? Mass and velocity. And just keep track, right? An electron, you got to look up the mass. The charge is going to be the electron charge, right? So 1.60, or the elementary charge. Coulombs, right? That's this. And then the potential is what we're trying to solve for. And then 1/2. Electrons are 9.11 times 10 to the minus 31st kilograms. And then 3.44 times 10 to the 6th squared. I guess I'm going to do this times this times this, divide by that. Here we go. Let's try it. So 0.5 times 9.11 E minus 31 times 3.44 E6 squared divided by 1.602 E minus 19. It's a syntax error. Okay, well, fine. Where is it? Oh, 2 times is fine. 33.6 volts is what I'm getting. Now, let me just say, if you accelerate it through, the rest mass of an electron is 511 kiloelectron volts. That means that's the energy equivalent of this, right? E equals mc squared, right? So there's a unit of energy called an electron volt, which is an electron accelerated through 1 volt. If you accelerate it through 511,000 volts, you'll actually double its mass, okay? Because the mass of the electron is going to be its rest mass, right? When it's not moving, plus the kinetic energy divided by the speed of light squared, right? That's this concept here, right? And so if you give it an amount of kinetic energy equal to its rest mass, you can actually double its mass. So this formula doesn't work so well then.